uh, fluid at rest and in motion. We say is fluid can be a fluid can be liquid and it can also be gas. A fluid, it can be liquid and gas. A fluid can be liquid and can be gas. So under this topic, we shall be looking at surface tension. Surface tension. What is surface tension? We say surface tension is defined as a phenomenon whereby a body behaves as if it is covered with an elastic skin. Surface tension is a phenomenon whereby a body behaves as if it is covered with an elastic skin. So let's put it down. Surface tension. So you can say it's a process or a phenomenon. Process whereby a body behaves as if it is covered with an elastic skin. Elastic skin. It's a process, or it is a phenomenon whereby a body behaves as if it is covered with elastic skin. How do we express surface tension? We can express it mathematically. We say surface tension. Surface tension is the force per unit length, which you have F all over L. So the SI unit of surface tension is Newton per meter. SI unit of surface tension is Newton per meter. So let's quickly look at the application. But before we look at the application of surface tension, let's look at the application of surface tension. Let's look at one of the application is in cleansing action. Cleansing action. Cleansing action of soap or detergent. Soap or detergent on materials. Then the second application of surface tension is in construction, or you call it manufacture of raincoats. The raincoat that we put to prevent us from getting soaked during the rainy season. That's the application of surface tension. This surface tension we are talking about, how can you reduce it? Can we reduce surface tension? Surface tension can be reduced. What method? How do you reduce it? Reduce surface tension. One of the main ways we can reduce surface tension is a method or ways of reducing surface tension. One, by heating the liquid. When you heat the liquid, it helps to reduce the surface tension. It reduces the surface tension. Then another method you can use to reduce surface tension, application. By application, you say by application of soap or detergent. When you apply soap or detergent to a liquid, it helps to lower or reduce the surface tension of the liquid. And the third method is by disturbing the liquids. Disturbing what? Is by disturbing the liquid. When you have a liquid in a container and the liquid is settled, when you continue to shake the container, it helps to what? It reduces the surface tension of the liquid. So these are methods you can use to reduce surface tension, and the application of surface tension, the definition of surface tension. Let's take a quick look at another term under the surface tension. There are some forces that we need to look at when you are dealing with a fluid at rest and in motion. Those forces are called the force of cohesion and the force of what? Adhesion. Adhesion and cohesive forces. So let's look at adhesion and cohesive forces. Let's look at it. Adhesion. Adhesion and cohesion. Cohesion. What is adhesion? What is adhesion? We say adhesion is the force of attraction between molecules of different substances. Adhesion is the force of attraction between molecules of different substances. Let's put it down. We say adhesion is the force of attraction between molecules of different substances. Molecules of different substances. Molecules of different substances. So when you're talking about adhesion involves the force that brings molecules of different substances together. For example, when you look at like water. When you have water in the container, you notice that let's say something like a glass, water with glass. They can ask you, water with glass. Why did water with glass? Water with glass because of the strong the strong force of what attraction between the molecules of water and the molecules of what a glass. That's the reason why water with glass. You understand? So example, you say water with glass because the force of adhesion between the two substances is what? Is greater than the force of what? Cohesion. Cohesion. The force of adhesion, that is the force of attraction between the molecules of water and glass, is greater than the force of cohesion. What is cohesion? Cohesion is the force of attraction between molecules of the same substance. The force of what? Attraction between molecules of the same substance. So the reason why water with glass is that the force of what? Adhesion between molecules of water and glass is greater than the force of cohesion. It's greater than the force of what? Because it's greater than the force of what? Cohesion. So let's look at another one situation. We have some substance like mercury. Mercury does not weigh glass. Mercury. Let's look at cohesion and we'll look at it in terms of mercury. Cohesion. We say cohesion, we say it is the force of attraction between molecules of the same substance. Molecules of the same substance. Cohesion. So under this cohesion, let's look at mercury. Mercury is a substance that does not weight glass. Mercury does not weight glass. Let's look at it. Mercury, the chemical formula of Hg, does not weight glass because the cohesion, the force of cohesion of mercury is greater than its adhesive forces, because greater than its adhesive force. So you see the reason why mercury does not weight glass. Mercury does not weight glass because the molecules of mercury tend to attract to each other better, you understand, than getting attracted to molecules of glass. But when you look at water the molecules of water, they tend to attract better to the molecules of what? Glass. So that's the reason why we say water with glass, because the force of adhesion of water to glass is greater than its force of what? Cohesion. Are we together? So we have talked about surface tension. We have looked at application of surface tension, then method of reducing surface tension. Then we'll look at adhesion. So let's take a quick look at another phenomenon. That phenomenon is what is called, we call it capillarity. Capillarity. That's what we look at. Capillarity is the ability or the tendency of it to rise or fall in a capillarity. Capillarity is the ability of a liquid to rise or fall in a capillarity. And capillarity, this tendency occurred as a result of these two fundamental forces, the force of cohesion and the force of adhesion. So let's put it down. Let's put it down quickly and see how it's put down. Capillarity. So let's put it down. We say capillarity. Capillarity. It is the tendency of a liquid, or you call it fluid, to rise or fall in a capillarity. This phenomenon occur due to the force of adhesion and cohesion. It occurs due to the force of adhesion and cohesion. So let's look at some practical example or situation where capillarity takes place. But before we look at that, capillarity, just like we talk about mercury rise water with glass, because the force of adhesion is greater than its force of cohesion. Then we say mercury does not weigh glass because the force of cohesion between molecules of mercury is greater than its force of adhesion. Then when you look at capillarity, in capillarity, there are some liquid that rise in the capillarity. There are some liquid that does not rise in the don't rise in the capillarity. For example, water rises in the capillarity because the force of cohesion between water and the molecules of the capillarity is greater than its force of cohesion. Are we together? The force of adhesion between molecules of water and the material, the capillarity, the material or what? The material, you understand? Or the capillarity is greater than what? Is greater than its force of cohesion. So if you have a capillary tube like this, let's say you have, this is a beaker, let's say, or a water bath, you have a capillary tube here. You see what we have? If you have something like this, this is water. You can have this is, let's call this water. You see, in this case, this is water. This is a water bath. This is a capillary tube. You can see. In this case, you can see water rise. This is water rise in this capillary tube. Water rise here. Water rise in this capillary tube because the adhesion is greater than what? Cohesion. That's why water rises in a capillary tube. Then you look at for mercury. If you have the same container, you have a capillary tube here, then you have a bath here, then you have some substance. You have substance like this. You have this is mercury. Then you have this a water bath. Then this is a capillary tube. This is a capillary tube. Then you see in this situation, this is the water here. So at this point, you notice that this is, you can see the level here. You can see the level. You can see the level of water in the level of mercury in the water bath here is greater. Look at the level. This is the height here. Then look at the level of what? The mercury in the capillary tube. It's telling you that mercury does not rise in a capillary tube. But when you look at water, you can see the level of water in the capillary tube is greater, is what? Is higher than the level of water in the water bath. Telling us this one means that water rises in the capillary tube. And water rises in the capillary tube because the force of adhesion of what? Water to the capillary tube is greater than the force of what? Its cohesion. Then in the case of what? Mercury. Mercury does not rise because the cohesive force, cohesion, is greater than what? Adhesion. That's the simplified way of explaining this concept. Then we have some areas where this phenomenon takes place. Capillarity, application, or examples of what? Capillary action. We call it examples of capillary action. What are the examples? Capillary actions. One, you can see this is our marker. You can see the ink. The ink here, the ink rise to the nib of this marker. The reason why the ink rise to the nib of this marker is because of the phenomenon of capillarity. Or pen, when you have something like your biro or your pen, you say ink rise up the nib of what? Of a pen. It's as a result of capillary action. Then blood spreading. You see, look at blood spread in the capillary channels of the woman body, of the woman body. It's an example of capillary action. Then with the other one we have in the candle wax. You know, the candle wax rise up to the what? The wick of what? The candle. That is the candle. In the candle wax, candle wax. We have the candle or wax. So these are some examples. These are basic examples. Then water rise. Water rise to the stem of a plant. Stem of a plant. The water rise from the soil. It move and get to the stem of a plant. This is as a result of capillary action. So this is all about fluid at rest and in motion. It's a very interesting aspect of physics. So I'd like you to like this video, subscribe, and you can share it with your loved ones. So have a wonderful day and God bless us all.